This lesson teaches RYA Coastal Skipper and Yachtmaster theory students all they need to know about charts, nautical almanacs, and other publications commonly used by navigators. Whenever we put to sea, it is essential that we go equipped with all the navigational information appropriate to the passage we are about to undertake. Obviously, the breadth and depth of information necessary to support a short coastal passage will differ from that required for a vessel embarking on an ocean voyage. At the very basic level, you will require charts and a nautical almanac. These might be supplemented by tidal atlases, pilot books, and lists of lights and fog signals. Traditional paper charts are rapidly being superseded by electronic charts, but whichever you choose, it's essential that you understand how they are created, their limitations, and how to interpret what you're seeing. In order to represent the Earth's surface on a chart, cartographers have developed many mathematical and geometric algorithms called projections. For navigators, the most useful are Mercator, Transverse Mercator, and Mnemonic. Mercator charts represent all parallels of latitude as straight horizontal lines and all meridians of longitude as straight vertical lines. Parallels of latitude and meridians of longitude therefore intersect at 90 degrees, forming rectangles, which are properly known as graticules. Any two positions can be joined by a straight line, called a rhumb line, and a vessel can sail a steady course along the rhumb line to find her destination. Your RYA Chart 3 is a Mercator chart. From a navigational perspective, whilst it's certainly true that you can follow a rhumb line course of any distance, for example Plymouth, UK to New York, if you did, you'd travel 3,105 nautical miles, whereas the actual distance on the Earth's surface is only 2,893 nautical miles. These actual distances are called Great Circles, or the Great Circle Course, and if you ever go on to study ocean navigation, you'll learn how to calculate and navigate Great Circle courses using a mnemonic chart, or these days a computer. Try this if you're in Great Britain and you've got a GPS to hand. Enter a waypoint in the centre of New York, and ask the GPS to navigate to the waypoint. See what initial course it suggests and the distance. Because GPSs give BTW, bearing to waypoint, via a great circle, the initial course from Great Britain to New York is 288 degrees, even though New York is around 600 miles south of, for example, Plymouth. The difference between a great circle course and a rhumb line is insignificant in coastal navigation. Mercator projections distort shape as the lines of longitude are opened up in the projection. It also makes areas like continents, countries, and oceans at high latitudes appear larger than those of similar area near to the equator. All the circles on this chart are equal in area. However, whereas it has been suggested that this somehow disadvantages countries near the equator, it is not a significant issue for navigators unless they are near the poles. Charts might be relatively small scale, like this chart covering over approximately 4,500 square miles, and useful for planning a passage along the central south coast of England. Note the scale is said to be 1 to 150,000 at latitude 51 degrees. The qualification at latitude 51 degrees is necessary because this is a Mercator chart, and as you've already learned, the further you are from the equator, the larger, scale, the chart. Whereas this one is drawn to a much larger scale of 1 to 5,000 and might be employed to create a pilotage plan for navigating Lymington River. Scale is therefore relative, not absolute. 1 to 5,000 is a larger scale than 1 to 50,000. If you find it hard to remember the mathematical basis of scale, just remember that large-scale charts make things look larger, small-scale charts make things look smaller. Remember that when we measure distance on a Mercator chart, we use the latitude scale running up and down the side of the chart, with 1 minute of latitude equaling 1 nautical mile, m. For example, it's approximately 4.75 miles from the gas production platform Alpha Juliet Delta 1 to the red port hand lateral buoy on West Point Ledge. And remember that because the scale increases as you move away from the equator, it's important that you measure a latitude roughly equivalent to the start and end points. The transverse Mercator projection produces an accurate grid that shows good detail in a smaller area. As the center point of the projection can be chosen specific to the area the chart covers, they are highly accurate representations of small areas of the Earth's surface showing little distortion. Your RYA Chart 4 is a transverse Mercator chart. We don't use the latitude scale to measure distance on transverse Mercator charts. Instead, we use a scale much like one found in any road atlas. In this example, the distance between number 1 and number 5 green starboard hand lateral buoys is 1 nautical mile, or 1,852 meters. Note that capital M is the abbreviation for miles, and lowercase m is the abbreviation for meters. Also remember that a cable is 1/10 of a nautical mile. Of course, all charts are based on large-scale surveys undertaken by skilled hydrographers. These might be national agencies, like the Specialist Hydrographic Branch of the British Royal Navy, or private companies contracted by national agencies. Charts may show a source data diagram, informing the user when different parts of a charted area were last surveyed. If you carefully study the source diagram in the top right-hand corner of your RYA Chart 3, you'll discover that some areas have not been surveyed for decades, and, in one case, Area G, not for 100 years. You might think basing a 21st century chart on a survey over a century old is unusual, but that is far from the case. 19th and 20th century hydrographers were remarkably skilled, and, within the context of their chart, established the position of geographic features with remarkable accuracy, via triangulation. The qualification is, however, within the words, within the context of their chart. For example, they could chart the position of a dangerous rock relative to other geographic features within a few feet either way. However, whilst everything was pretty much perfectly charted relative to everything else, there had to be some starting point, which is known as a datum point, or datum, and its position could only be determined by reference to other datums, and they, in turn, to other datums, and so on, thereby introducing a significant degree of error. The datum for a chart of a remote island could only be fixed by astronomical observation, using a sextant and chronometer. Even a skilled navigator taking multiple sights could well be half a mile out. The result is that many places simply are not where they say they are on the chart. This never mattered before the days of GPS, because navigators either established the position visually, and therefore relative to other geographic features on the chart, or navigated with extreme caution, avoiding dangers by a large safety margin. Many paper charts carry warnings to this effect. Navigators ignore them at their peril. You also need to consider that until the early 1990s, all bottom surveys were conducted with either, and originally, a lead line, or from about 1940 using a straightforward depth sounder. This means that surveys conducted before 1990 might have missed significant underwater obstructions, such as rocks, in between sweeps. For example, imagine that you are navigating close inshore around the infamous Casquets, perhaps into the charted anchorage to the south, or to cheat a foul tide. You might be tempted to rely on your chart plotter to keep you clear of the rocks, but if you did, you'd be relying on surveys conducted in the mid-19th century. A related issue is choice of horizontal, or map, datum. Imagine that you were Captain Blackbeard, and you needed to bury some treasure on a desert island, making it simple for someone with the correct instructions to retrieve it at a future date. One way would be to specify the treasure's position relative to some distinctive feature. In this example, Skull Rock. Blackbeard's treasure is buried 100 paces north and 30 paces west of Skull Rock. Skull Rock is our horizontal, or map, datum. However, the choice of datum is entirely arbitrary. Blackbeard could have chosen something else as his datum, perhaps a distinctive tree, in which case the measurements relative to the alternative datum would be completely different. And if you confused your measurements and datum, you would not only fail to locate the hidden treasure, but you'd also risk falling off a cliff. Over the centuries, cartographers have come up with a multitude of datum, some two-dimensional, some three-dimensional, some intended for mapping a relatively small area, such as a single Caribbean island, others for entire continents, and, latterly, as a global standard. Those intended for global standardization are at some theoretical position in the center of the Earth. Like Blackbeard's Island, the Earth is not a perfectly regular shape. It's slightly squashed top and bottom into what is known as an oblate spheroid. It also has surface irregularities. So there's no perfect geometrically precise center of the Earth for cartographers to use a common datum, and, over time, national and international bodies have chosen many different points as their datum. WGS, World Geodetic System, 84, is the latest international standard, and gradually all charts are being redrawn to WGS 84. However, there are still many, many charts that are not. GPSs intended for serious navigation, like this Garmin GPS 128, will allow you to select from a wide range of datum. And if you are navigating using a GPS in conjunction with paper charts, you should always check to ensure that your GPS is configured to give positions relative to the same datum as the chart. In this case, it would be WGS 84. However, this chart is drawn relative to Ordnance Survey of Ireland datum, and most GPSs will not offer this as an option. Unless you can change your GPS receiver settings such that it refers to the same datum as the chart, you need to make manual adjustments when entering the latitude and longitude of your waypoints. You should also use visual fixing methods whenever possible to check that you are approaching waypoints safely. Of course, none of the foregoing mattered in the slightest before the advent of GPS, because navigators fixed their position relative to charted features without any regard to latitude and longitude. So it didn't matter what datum the chart was drawn to, or indeed whether the chart was accurately positioned by latitude and longitude. If they could not plot a visual fix, they assumed that their position was inaccurate and navigated with extreme caution. Imagine, for example, that you'd placed a waypoint west of Carrickapane to keep you clear of the off-lying reefs, but had failed to make the necessary adjustment for WGS 84. You'd end up crossing the reefs in an area with a charted depth of less than 2 meters. Not funny in a deep draft yacht near low water. Regarding electronic charts, or electronic navigation charts, ENCs as they are properly known, the first thing to consider is raster versus vector. Basically, raster charts are no more than facsimiles of paper charts, and because of this are incredibly cheap and at the same time very reliable. Obviously, they employ the same chart projection as their paper source. Vector charts, on the other hand, are made from tracings of paper charts, which are stored in layers in a database. They tend to be much more expensive, and there have been problems with them not properly depicting or even missing features that appeared in the original paper chart. Take a look at these two charts. You can see that the raster chart shows considerably more detail. Actually, there's a bit of a misconception amongst many people that when zooming in and out on raster charts, all you see is the same detail bigger and smaller. However, whilst this is true if you stick with a single chart, most chart plotter software is smart enough to switch between facsimiles of larger and smaller scale charts as you go in and out. Let's see the difference when we zoom in on raster and vector charts. Raster charts can, however, look a little strange when they mix chart surveys to different scales. Vector charts allow you to turn features on and off to declutter the screen. They also typically allow you to change the coloration of the contours, which can be useful when you're navigating close to shore or in the areas frequented by big ships, as it makes it easy to identify the areas you want to keep out of. Here we've set the safety contour to 2 meters, to warn us of areas that we need to keep clear of near low water. And here it's been set to 10 meters, which highlights the main shipping lanes which we might want to avoid in poor visibility. The next thing to understand is that there are electronic charts and electronic charts. If we ignore raster charts, the gold standard are those published by national hydrographic offices such as UKHO, and are intended as complete replacements for paper charts. Unfortunately, they are priced beyond the means of all but large commercial operators or superyachts, and do not run on the types of chart plotter likely to be found on small craft. Small craft vector charts, especially those intended solely for leisure use, are created by companies such as Jeppesen, Navionics and Garmin, amongst others. They are based on National Hydrographic Office's data, but traced and compiled by their publisher. They are not subject to the same rigorous standards and quality control as those produced by National Hydrographic Offices, and it can, for example, be quite difficult to determine the source data. It's also pretty usual for their publishers to absolve themselves from all responsibility for the accuracy of their data. Charts are referenced by catalogue number, which is found in the corners of the chart. Take a look at your RYA charts 3 and 4. They also show an edition number and date. If you're buying paper charts, check the relevant catalogue to discover the latest edition, number and date, to ensure the dusty old chart you found in the Chandler's is the latest edition. Of course, paper charts start to go out of date the moment they're published. Natural features such as coastlines and rocks don't change, although sandbars might. However, man-made features, for example lights, offshore structures, rules and regulations, change continually. So, National Hydrographic Offices publish regular chart updates. In the UK, necessary chart corrections are distributed via Admiralty Notices to Mariners, published by UKHO. You can subscribe to them in paper form, however they are available free online from this link, which is also available from the Resources tab. This chart has been updated at source to Notices to Mariners 2006 8195 8812. Paper charts should be regularly updated by hand, and a part of the service provided by good chart agents is to continually update their stock of paper charts so that when you buy one, it is up to date. This one has been manually updated to Notices to Mariners 8935. However, don't expect your local chandler to do the same. UKHO have published this excellent video all about updating paper charts on YouTube. You might care to view it. However, it is
Notices to Mariners consist of textual NMs, tracings, blocks, and notes. The textual NMs are your primary source for updating a chart. The tracings and blocks show the information from the textual NM in a graphic form, so that you can apply the updates quickly and accurately. It's important to always cross-reference the tracings and blocks with the textual NM to ensure all changes are applied correctly. On receipt of these items, identify which of your charts are affected and record the relevant NM number in pencil against the chart number in your paper chart maintenance record NP133A. The date of new additions, new charts, or withdrawn charts should be entered in ink as a permanent record. Updates can then be applied with the use of tracings or NM blocks. Tracings are produced in two sizes, either A4 or A5. Each tracing displays the chart number, the new chart or new addition date, and a small grid for quick reference of where the update is located on the chart. For example, if the cross is in the lower left box, then the update will be in the lower left corner of the chart. The tracing will also show the previous update. Before you apply any new update, it's important to make sure that the chart contains the previous update. You can do this by checking the NM number in the bottom left corner of the chart. After applying an update using a magenta pen, write the notice number in the bottom left-hand corner of the chart to record the completed update. If applying a year date, underline it so that it won't be confused with an NM number. Finally, using a 2B pencil, cross through the appropriate NM number in NP133A to show the update has been applied.
Electronic charts might be supplied on cartridges, disk, or via download from the internet. Each publisher has its own way of distributing corrections, normally via subscription service, and possibly requiring special hardware to update the chart cartridge via a personal computer. Beware! Corrections to electronic charts aimed at the leisure marine market are not published as regularly as Notices to Mariners, and it can be very difficult or impossible to discover exactly how up-to-date an electronic chart is. So, unless you know for certain that your chart is bang up to date, Don't be surprised if reality diverges from what you expect from inspecting your paper chart or chart plotter. Charts incorporate a very large set of symbols and abbreviations. Some are given on pages 6, 7 and 9 of your RYA Training Almanac, but for a full set you need either an Admiralty UKHO Chart 5011, which is available from Chandler's, Chart Agents and Amazon, or a copy of US Chart number 1, which is free and available to view and print from either the Resources tab or the Learning Management System. Nobody could be expected to memorize all the thousands of symbols and abbreviations. If you see something on a chart that you don't recognize, try to find something that looks similar inside the back cover of the 5011 or chart number 1, then search for it in the relevant section. Paper and electronic charts use different sets of symbols, and not all publishers of electronic charts use the internationally agreed standards. Apart from an appropriate selection of small and large-scale charts, a nautical almanac is essential. There are many different publishers and formats. Some are starting to be released in digital format. Reed's Nautical Almanac is pretty much the standard for British leisure mariners in Western Europe. This version costs around £35 and includes 700 chartlets, harbour facilities, tide tables and streams, 7,500 waypoints, international codes and flags, weather, distance tables, passage advice, area planning charts, rules of the road, radio information, communications, safety, first aid, documentation and customs, as well as a free Reed's Marina Guide. If you can, see if you can lay your hands on an out-of-date almanac. Whilst the tide tables will be useless, there's a mine of information and reference matter that rarely changes year to year, and it's well worthwhile spending a few hours perusing the contents. Your RYA Training Almanac pretty much mimics a Reed's Almanac. Take time now to go through it to get some idea of what's included. Incidentally, students sometimes struggle to find places named in exercise questions. The secret is to look inside the front cover of the Training Almanac, where you will find a small-scale chart of the entire RYA training world, and, on the opposite page, an alphabetic list of place names within the northern and southern peninsulas. Real almanacs, like Reed's, are organized into sections, and provide large-scale charts for each, with section references marked on the chart. Pilot books, or as UKHO calls them, sailing directions, are a very valuable addition to the Navigator's Reference Library. Again, there are many different publishers. Tom Cunliffe's excellent Shell Channel Pilot is pretty much universally adopted as the standard for the English Channel. The Royal Cruising Club Pilotage Foundation does an excellent job commissioning and publishing pilot books especially intended for yachtsmen, and covering some of the remotest parts of the world. A good pilot book will provide you with seasonal weather statistics, sailing directions to the area, large-scale charts, recommended tracks and visual references with pictures, local rules and regulations. It will also tell you where you can buy fuel, gas and water up. Some even make restaurant recommendations. Most almanacs provide a lot of very similar information, but usually at a lower level of detail. And in some parts of the world, pilot books are available, but almanacs are not. Nautical almanacs and Admiralty lists of lights and fog signals provide a full list of lights per geographic region. Depending upon the source, they might be organized in sequence along a coastline or by region, for example a harbour or estuary, and might disregard lights or buoys of less than a minimum height or luminous range. Unlike the examples given in the RYA Training Almanac, for example on page 31, which are not representative of the real world, they give the geographic position of each light, enabling the navigator to quickly establish the identity of a light by its observed characteristics. Whilst almanacs normally include basic tidal atlases, you may choose to equip yourself with specialist publications, such as those provided by UKHO and commercial publishers such as Reeves Fowkes. We will be covering their use in detail later in the course. Commercial electronic chart providers are incorporating new features into their charts. For example, photographs, satellite overlays, and 3D views. And of course, there are a plethora of apps and web resources, some good, some pretty dubious. Treat them with caution. It's always worth checking local notices to mariners published by individual harbour authorities. Laying your hands on these used to be a bit of a problem, but thankfully the internet has changed all that. Simply search for the harbour you're interested in, along with the keywords Local Notices to Mariners. Well done! You've completed the lesson on charts and other publications. Now go on to attempt exercise A.